Right now, we are looking at pages 17 and 18. We are translating equations into word problems, and we are solving them to find the answer. I'm doing these three with you. I think they're the most challenging, so anything we do in here will apply to those. This is more of the same. You'll be doing a whole lot of this from now until the end of the school year. Number 5. 4 times the number increased by 3 is the same as, that's my equals. 4 times the number increased by 3, this is one side. 4 times the number increased by 3 is the same as, now the other side of the equation. Twice a number increased by 9, find the number. Twice a number increased by 9, find the number. Here is where we solve. My first goal is to get all the n's on the left side and all the constants, plain numbers, on the right. So the first thing I'll do is I'm going to get rid of that because the 2n is on the right side and I want it on the left side. So I'll take away 2n from both sides. And when I do that, hey Amber baby, sweet baby. When I do that, I have 4n minus 2n, 2n plus 3 on this side equals, no 2n here, 9. Now let me get all the constants to the right. So I've got to get this 3 over here. To get rid of this so I can get the 2n by itself, I'll do the opposite. I'll subtract 3 from both sides. That gives me 2n on this side equals 9 minus 3 is 6 on this side. Now I will isolate just the variable. The opposite of times 2 is divided by 2. So I divide both sides by 2. I'm left with n equals 3. So for number 5, n equals 3. 4 times 3 increased by 3 is the same as twice 3 increased by 9. Number 6. 3 times a number increased by 7 gives the same result as 4 times a number increased by 5. Gives the same result as, there's my equals. So let me do one side at a time. 3 times a number increased by 7. 3 times a number increased by 7 equals 4 times a number increased by 5. 4 times a number increased by 5. This is very similar to the one in front of it, before it, to number 5. Once again, I want to get all of my variable terms on the left. So to get that away from the right side, I'll do the opposite. So I will take away 4n from both sides. Minus 4n, minus 4n. This leaves me with negative n. 3n minus 4n is negative n. Plus 7 equals, I got rid of my 4n, 5. I'm left with 5. Now, I'm going to get my constants over there. So to get rid of that 7, I'll subtract 7 from both sides. So negative 7, negative 7. That leaves me with negative n equals 5 minus 7 is negative 2. If negative n is negative 2, then positive n is positive 2. Got it done. So the value of n in number 6 is 2. N equals 2. On to number 7. If 7 is added to twice a number, the result is the same as, there's my equals, if 11 is added to the number itself. Okay. 7 is added to twice a number. 7 is added to twice a number. The result is the same as if 11 is added to the number itself. So if 11 is added to the number itself, that's the number. Here is my equation. All right, so my first goal, again, is to get all my variable terms to the left and all my constant terms to the right. So I will subtract n from both sides. And that gives me 7 plus n, 2n minus n is n, equals 11. Now, I want to get this 7 over there to isolate the variable. So the opposite of positive 7 is negative 7. That gives me n equals 11 minus 7 is 4. The value of n in 7 is 4. N equals 4. I would say when you do the others, focus on starting with finding the equal sign, and then do one side and then the other before you solve them. And I don't think there's enough room on this page to write all your steps. So you'll want something else to write your steps. The next part we'll do is the bottom. This is merely substitution. I'm doing some with you because we've got fractions and decimals. It's all the same. But sometimes when you see something like that, sometimes it might be a little intimidating, but they're really all the same. We'll start with number 5. 4.5x plus 2x. X is 8. So that means we have 4.5. We'll add in a multiplication symbol, plus 2 times 8. Now we'll do multiplication. And you remember how to multiply decimals. First thing that we'll do is we'll convert this to a mixed number. Be 9 halves, so we've got 9 halves times 8 over 1, so we've got 2 fractions. We'll convert that to an improper fraction. Excuse me, I said that wrong. We can actually cross-reduce. That is 1, that is 4. I reduce them by 2. 9 times 4 is 36. 1 times 1 is 1. Oh, so we end up with 36. 4.5 times 8 is 36. Plus 2 times 8 is 16. When we add those together, we get 6 plus 6 is 12, carry the 1, 52. You see? It's the same as you would ordinarily do it, but you might have to step aside and write out your fraction multiplication. Decimals are even easier. Number 4. M is 2.1. So I will write this 3 times 2.1 minus 4.2. So 3 times 2.1 would be like 3 times 21 is 62. I have one digit to the right of the decimal, so in my product I'll have one digit to the right, just like that. 6 and 2/10 minus 4 and 2/10. When you subtract, you get 2 wholes. On to number 6. X squared plus 2y. If x is 2.5, 2 and 5/10, y is 3. 2.5, 2.5, 2 and 5/10, it's all the same. X squared. 2.5 squared plus 2 times y. I suggest for this you use a calculator. It's basically 225 squared. And then you put in the decimal at the end. As far as the computation part, you treat it like 25. It's, if 2 squared is 4, then it's going to be, 2 squared is 4, 3 squared is 9. It's going to be bigger than 4 and smaller than 9. Let's see. 2.5 times 2.5 equals 6.25. 6 and 25 hundredths. So it's bigger than 4, smaller than 9. Just so you know, 25 squared is 625. So 6 and 25 hundredths plus, I forgot to substitute the 3. There we go. 2 times 3 is 6. Now I have 6 plus 6 is 12.25. That gives me 12 and 25 hundredths. So after the lesson, of course, come back and finish this page. Now we'll move on to the next page. I like doing these. These are a pretty easy way to practice these and to pay careful attention to little details when they're already written, so you don't have to come up with it on your own. We'll do 3 together. You've got the rest on your own. This isn't too difficult, this page particularly. Find 7 times as much as. Just think of 7 times, or you can even get rid of that. 7 times 6 less than 10. I don't like the words as much as. You see those from time to time. To me, it seems wordy and unnecessarily wordy. So, in fact, you can just do find 7 times 6 less than 10. Actually, I think I like that better. You don't even need that. 7 times 6 less than 10. So 6 less than 10. 6 less than 10. 7 times that. 6 less than 10. So it's going to be 10 minus 6. This is it right here. 7 times 6 less than 10. Just like that. Number 9. Find 1 less than 18 and then find 28 less than the difference. Find 1 less than 18. We do this part first. 1 less than 18. That would be 18 minus 1. 1 less than 18 is written like that because you're starting with 18 and taking away 1. And then find 28 less than the difference. Since I'm starting with the difference, I've got to find the difference first. Find 28 less than the difference. So 20 less than that. So I start with that and I take away 28. They really tried to trick you here. So that would be this one. It's easy to get these numbers mixed up, the order of the numbers mixed up. And finally, number 12. Add 3 to the quotient of 4 divided by 9. This is wordy too. You could either say add 3 to 4 divided by 9, or the best way to write it would be add 3 to the quotient of 4 and 9. They're wordy in here, aren't they? So add 3 to the quotient of 4 divided by 9. 4 divided by 9. Or in this case, 4 divided by 9, it's the same. No. Well, can't be that one, can't be that one, can't be that one. So add 3, so it's obviously that one. That's the only one that has 4 divided by 9 in it. They made that one easy when you roll out the ones that obviously are not it. All right, so finish this page and then go back and finish page 17. And that's it for today.